Hey, good evening. Tonight we're going to be talking about electron domain geometries, and we're going to be reconciling that with molecules that have lone pairs. So even though the molecular formula is not written with what we see as atoms, we know that there are additional electrons changing the shape of the molecule. So we're going to attempt to reconcile some of that today with balloons. Okay, so first off, I wanted to start talking about the way the balloon demonstration is going to go. We are going to represent, the balloons will be representing electron domains, so that can include lone pairs. And what will not be represented is any kind of central atom that will be represented by the connection of the balloons, however many there are. Okay. We're going to start with a fairly basic concept. I'm adding an extra one to our assignment. This is a simple linear molecule with no lone pair. So in this case, for example, I have two electron domains. This is an AB2 molecule. This is linear geometry for the electron domains because there are no lone pairs. And of course, there's no lone pair placement. And an example for this particular molecule would be carbon dioxide, CO2, since that central carbon is double bonded with the two additional oxygen molecules. Okay, if we were to add a lone pair to this central molecule, we would then come up with three different electron domains. Okay, this is now an AB2 molecule because this pink balloon represents a lone pair. This changes the electron domain geometry to trigonal planar. And again, one lone pair in this. And the lone pair placement would actually be kind of settled right on top of that central atom, causing an actual bent. I'm going to take this away just to represent. This is going to be more of a bent molecular geometry, something along those lines, with this pink lone pair kind of hanging out on top. An example of this molecule is sulfur dioxide. Okay, so what if we have this same molecule that I just demonstrated, and we were to add a third atom bonded to the center? Okay, now we have what is 4 electron domains. We have an AB3 molecule. The electron domain geometry is tetrahedral. And again, we still have one lone pair here. And the lone pair placement is causing the other 3 bonded atoms to kind of be deflected down. So this would represent a trigonal plane pyramidal molecular shape. And an example of this is NH3. Okay, grabbed a few more balloons and we're going to keep moving on. We are now moving into having 4 electron domains, but with a slightly different configuration. I'm going to be working with another AB2 molecule, meaning I have one central atom and 2 additional bonded atoms, but that means I also have 2 lone pair, and that's going to cause a tetrahedral formation of the electron domain geometry. However, since we have one central atom, 2 additional atoms that are bonded, and then the 2 lone pair, that's going to cause a bent formation in the molecular geometry, something like this, with the blue representing the hydrogen and the yellow will be representing the lone pair. And you have our 4 electron domains. An example of this is water. Okay. Continuing, we are going to move on to different electron geometry. Now we are now going to be talking about 5 different electron domains with an AB4 molecule, and this will be a trigonal bipyramidal molecule with one lone pair. So that means one central atom, 4 additional bonded atoms, and one lone pair makes 5 things bonded to a central atom. And I've represented that right now. 3 white balloons are my bonded atoms. We'll call the yellow balloon a 4th bonded atom. And this pink balloon, that's the bonded, lone pair. This is what we call a seesaw configuration for the molecular geometry. And an example, a molecular example of this is sulfur tetrafluoride. Okay, next one. I've got a demonstration here of a molecule with 5 electron domains. This is going to be an AB3 type molecule. Again, the electron geometry is taking on a trigonal bipyramidal. However, this time we have 2 lone pairs, and those lone pairs, again, are considered additional bonded items to the central molecule. So we have the 3 bonded molecules represented here by yellow balloons. My hands are holding some pipe cleaners that are the central atom. And then the 2 yellow balloons represent our lone pairs. The lone pairs will actually force this molecule into its most stable shape of being T-shaped. And an example of this is chlorine trifluoride. All right, I just wanted to correct something on that last molecule I talked about, the last electron domain geometry. I had said that the 3 yellow balloons represented bonded molecules. As you can see, I have 2 yellow balloons and 3 white. So the 3 white were the bonded molecules. The 2 yellow represented lone pairs. Okay, but now I'm going to change that for this next molecule. We still have 5 electron domains in the next molecule I'm going to talk about. It's an AB2 now, however. And it's still trigonal bipyramidal because we have 3 lone pairs. So we still have 5 electron domains that are impacting the shape of this molecule and 1 central atom. So in this particular case, now the 2 yellow balloons have become the bonded atoms. And the 3 additional white balloons here are the lone pair electron domains. And actually, this molecular shape takes on a linear shape with those 2 yellow atoms bonded to the central. And an example of this is an iodine fluoride compound. Okay, 2 more to go. We have a compound now that I've built with 6 electron domains. This is an AB5 molecule, which takes on an octahedral electron domain geometry. Specifically, this molecule has 1 central atom, 1, 2, 3, 4, 5 additional bonded atoms, and 1 lone pair. Lone pair here is pink, and then all the yellow and white balloons are represented as the bonded atoms to our central atom buried in the middle, which causes this particular molecule to take on a square pyramidal molecular shape. And an example of this is bromine pentafluoride. Okay, last molecule. We have 6 electron domains in this last molecule. And it's a molecule type of an AB4. So a 1 central molecule, 4 additional bonded molecules, but we have 6 electron domains, so that means we have 2 lone pair also in here. That means that electron domain geometry is going to be octahedral, and that the lone placement settle onto the central molecule, central bonded atom, and cause a square planar for the overall molecular geometry. And an example of this is xenon tetrafluoride. So I've built that right here. We've got 2 yellow and 2 white balloons, and those are representing our bonded molecules. And then, there we go, that's a little bit better. And then the 2 blue, there we go, the 2 blue balloons represent the lone pairs. And there you have it. Have a good night.